Hey 7th graders, this is Mr. Humphreys here, and you are in section 3.6, Equations and Problem Solving. Okay, here's the good news. The equations that you're going to be solving today are no harder than what you've been doing. Here's the bad news. They're all word problems, and these word problems can be difficult. They can also be frustrating. So stick with it. Ask questions, ask questions, ask questions. We will get through this, and you will be a much better problem solver. So let's start with kind of what we're getting into. In the past, you've maybe only had to find one thing, such as how many people went to the movie theater. So you had one variable and one answer. But now you're going to contain two or more unknown quantities. So to solve these problems, you are going to have to decide which unknown quantity the variable is going to represent. What are you going to let represent X or Y? Then everything else you don't know is going to be in quantities in terms of the variable that you just had. So let's start with an example. Now, all of these examples are right out of your book on page 158. So I would rather you not spend the time on copying every single one of these word problems down. You can, but you do need to show the work. You have to have the work, but the actual word problem, if you don't want to write it down, you do not have to. All right, example number 1. The length of a rectangle is 6 inches more than its width. The perimeter of the rectangle is 24 inches. What is the length of the rectangle? Step 1, and I will hound this over and over again. Define the variable. Tell me what you have to find. It says, what is the length of the rectangle? What is the length? So, let's write this down. We need to know what the length is. But we also don't know the width. I know it doesn't ask us to find the width, but we still don't know it. There are two things we don't know, the length and the width. Here's what you're going to do. You have to determine either the length or the width, which one you want to be your variable. Doesn't matter, but here's what I would suggest. Figure out the one it does not tell you anything about. So if you start reading the problem, it says that the length of the rectangle, yada, yada, yada. It starts talking about the length in terms of the width. So we're going to let the variable x, or whatever variable you want, be the width. So now, whenever you see the word width, you're going to plug in what you just let that be. So it says the length of a rectangle. What is the length of the rectangle? It's 6 more than the width. What's the width? Well, we let it be x. So the length has to be 6 more than that. So the length is going to be 6 plus x, or x plus 6. Now we need to find the perimeter. Now once again, there are many ways to set this up. I'm only showing you one way. There are other ways. So once again, we can draw a picture. Pictures are worth 1,000 words. You can absolutely do better with a picture. So we know the length is x plus 6. Since we're talking about the perimeter, we can label all 4 sides. Don't just add up these 2 because that's only 2 sides. So let's figure this out. Add all the perimeter together. So you add all 4 sides to give us the total perimeter. So we have 1x plus 1x plus 1x plus 1x. That's going to give us 4x plus 6, that gives me 12, equals a total perimeter of 24. Now you just solve this on your own. Subtract 12, divide by 4. So we get a value of x as 3. What's 3 then? Well, width was 3, but I don't want the width. I want the length. So we plug in the 3 here as well. 3 plus 6. That means the length is going to be 3 plus 6, which is 9 inches. So the length is 9 inches. All right, the next thing we're going to talk about are consecutive integers. Consecutive integers differ by 1. For example, you do not need to write this down. 1, 2, and 3 are consecutive integers. 51, 52 are consecutive integers. That's it. So let's do a problem with consecutive integers. Example number 2. The sum of 3 consecutive integers is 147. Find the integers. So we're going to start by looking at the integers. We need to find them. Well, there are 3 of them. So we're going to put 1, 2, 3. We have to find all 3. The first one we can always say is x. How do you get to the next integer after 1? So how do you go from 1 to 2? Or how do you go from 51 to 52? You add 1. So to go from x, we're going to add 1. The next integer is going to be x plus 2. If there were 4 integers, we would do x plus 3, and so on. So it says the sum. The sum means that you're going to add these up. So we're going to add all 3 of these together. So x plus x plus x, 3x, 1 plus 2 is 3. The total sum is 147. So our equation would be 3x plus 3 equals 147. So step 1, define the variable. Step 2, we wrote our equation. Step 3 is to solve it. So we subtract 3. That gives us 144. Divide by 3. That gives us 48. But we're not done. You have to then do the last step, which is always taking your value of x and plugging it in for whatever you have to find. So our first number is 48. Then we have 48 plus 1, which is 49. And the last one is 50. Our 3 consecutive integers are 48, 49, and 50. Example 3. The sum of 2 consecutive odd integers is 56. Note, this should be a red flag for you. Odd integers. If you see the word odd or even, you have one extra thing to do. So I'm gonna go to the bottom here, and I'm gonna write down, for example, 3 consecutive odd numbers. So those are odd. And then I'm gonna write down even numbers. This is important. The students always make this mistake. How do you go from one even number to the next? Plus 2, plus 2. So you go by even, and people are like, oh yeah, I got that. But look at odd. How do you go from 3 to 5? 5 to 7? It's also plus 2. Even and odd are always like x, x plus 2, x plus 4. It's weird because you think, well, how can it be plus 2 when it's odd? Because odd numbers have a difference of 2 if you're talking about consecutive numbers. So this odd, if you see odd or even, it's a red flag. You're going to do plus 2. So here we go. Find the integers. Well, we have 2 integers, so we're going to do first integer, second integer. Our first integer will always be x or y or whatever letter you want. Since we're talking about odd, how do you go from one odd number to the next? You add 2. If you wanted to find 3 numbers, you'd have x plus 4. If you had another number, x plus 6. It always increases by plus 2's. So then it says the sum. Well, sum is a key word to add them. So we just add these 2 expressions. So 2x plus 2 gives me a total of 56. I solve it, subtract 2. I divide by 2. And I get my value as x equals 27. Well, I take the 27, plug it into both these values. That means the sum of 2 consecutive odd integers, those odd integers are 27 and 29. And I forgot to mention that this example is actually on page 163, and this one is actually example number 8 in your book. We are now going to start talking about distance problems or motion problems. Now, you don't need to write this down, but uniform motion problems are problems where an object moves at the same constant rate. So, for example, you're going 40 miles an hour. You're going at a constant rate, 40 miles every hour. So, in order to do distance, rate, time problems, this formula is going to be used for everyone. Distance equals rate times time. Distance is obviously how far you're going. Time, it's in hours. And rate is the speed that you're going. Uniform motion problems may involve objects going the same direction, opposite directions, or round trips. So let's use a really easy example. How far would you go if you're traveling 40 miles an hour for 5 hours? 40 miles per hour for 5 hours. You would go 200 miles. That's it. Now you're like, where'd the miles go? Or where'd the hours go? Remember, if you're doing 40 miles per hour, this is just like the problems we did, times 5 hours, look what happens. Hours cancel. So that's why you're left with the label of miles. And here we go with the hard problems. Example number 4. A train leaves a station at 1 p.m. It travels at an average rate of 72 miles per hour. A high-speed train leaves the same station an hour later. It travels at an average rate of 90 miles per hour. The second train follows the same route as the first train on parallel tracks. In how many hours will the second train catch up with the first train? I'm going to tell you right now, whenever you do distance rate problems, I want you to use a table. While it's not necessary, I'm telling you right now, a table will help you. Here's how I do a table. This is what I do. I do D equals rate times time. And then we have our two things. So in this problem, what are the two things that we're talking about? We're talking about train number 1. So I'm going to put number 1 on the first line. And train number 2, I'm going to put number 2 on the second line. You could also label them train and high-speed train. It's up to you. So let's start figuring out what our speeds are, what our times are, what our distances are. So here we go. D equals R times T. A train leaves the station at 1 p.m. Well, that doesn't tell us anything. It travels at an average rate of 72 miles per hour. Hey, there's our first thing. Our rate is 72 miles per hour. All right, so a high-speed train leaves the same station an hour later. So we'll come back to that. It travels at an average rate of 90 miles per hour. The second train follows the same route as the first train on parallel tracks. In how many hours will the second train catch up with the first train? Well, what we don't know is time. But here's what we're going to do. The first train leaves at 1 p.m. Well, that's not how long it's been traveling. It's just time. We don't know that. So we're going to let this be X. But then the second train leaves an hour later. So if the first train, let's say, was traveling 3 hours, how long has the second train been traveling? 2. Because it left an hour later, it's going to be traveling 1 less. So we know that the second train is going to be traveling 1 hour later because it left. So this is rate times time. What do we know? Our distance for our first train is 72x. The distance for the second train is 90 times x minus 1. We have to multiply 90 times the entire thing. We want to know, when will the second train catch up? When it catches up, what do you know about their distance? It's the same. So we want to know when this distance is equal to this distance. So we're going to set our equations equal to each other because the distances have to be equal if they catch up. So we set 72x equals 90 times x minus 1, and we solve the equation. We distribute the 90, so we're going to get 90x minus 90. I'm going to subtract 90 on both sides, or subtract 90x. 72x minus 90x gives me 18x, negative 18x, equals negative 90. So if I solve, x would give me, x would give me 5. But And how many hours will the second train catch up? So this is key. How many hours after? Well, the first train is X, that's 5. The second train is right here, 5 minus 1. So after 4 hours, the second train will catch up. I could have said at what time? Well, if it was 4 hours after 1 p.m., it would have caught up at 5 p.m. So keep in mind, whatever I ask you is what you need to answer. You have to be precise. Now that problem was an example of the same direction. Both things were going in the same direction. All right, example 5. Noya drives into the city to buy a software program at a computer store. Because of traffic conditions, she averages only 15 miles per hour. On her drive home, she averages 35 miles per hour. If the total time traveled is 2 hours, how long did it take her to drive to the computer store? Notice this time, she's not going the same direction. It's called round trip. Round trip means you go to the place and then back. It's kind of like school. If you go drive, well, you're not going to drive, don't drive. But if you would ride your bike to school and ride your bike back, that's called round trip. So here we go. Let's set up our table. So distance equals rate times time. So what are we talking about? We're talking to the computer store and from the computer store. So here we go. Start reading it again. So first sentence is not important. Because of the traffic conditions, she averages only 15 miles per hour. So she's going to the computer store. So her rate is 15 miles per hour. On her drive home, so from the computer store, she travels 35 miles per hour. So now we have to figure out, what don't we know? Well, we do not know time. So, to the store, we can just say, okay, it's X. Or you can leave it as T. Let's use T, since we're talking about time. You can use whatever letters you want. Now, the only thing I know is it took her a total of 2 hours. If it took her T hours to go to the computer store, what did it take her to come back? Give you a hint. If it took her an hour and a half to go to the store, how long did it take her to come back? It took her half an hour, because we know the total has to be 2. So if it was T for to the store, to get the other one, you'd have to subtract 2 minus T. That gives us the difference. So if it was a total of 5 hours, it'd be 5 minus T. If it was a total of 3 hours, it'd be 3 minus T. So this is rate times times. We multiply them together. Her distance for the first one is 15T. Her distance for the second one is 35 times 2 minus T. So we want to know what the value of T is. Well, this is where you got to just use your brain. What do you know about the distance to the computer store and from the computer store? It's the same. It's like saying, what's the distance from your house to the school and your school and the school to the house? Well, it's not going to change. Your house is not going to be farther away when you go home. So we know that these are the same. So we're going to set these two equations equal to each other. Distribute and solve. So we get 15T equals 35 times 2 is 70. 35 times negative T is negative 35T. I now add 35 to both sides. That gives me, oops, not 5T. That would be really bad adding. That would be 50T equals 70. We divide by 50. 70 divided by 50, or 7/5, gives us 1 2/5, or 1 2/5. No one's going to say, how long did it take you? 1 2/5. Well, you're not going to say 1 2/5. So how long did it take? It took 1.4. So it took 1.4 hours. Are you sure you're done, though? Yes, because the question asked, how long did it take her to drive to the computer store? To the computer store was T. We found T, and so it would be 1.4 hours. If I asked how long it took her to go home, you would have to take 2 minus 1.4 to get 0.6 hours. Well, here's the good news. This is your last example, but we're talking about yet another kind of trip. So let's read it first, and then I'll explain. Example number 6, which is on page 162 in your book. Jane and Peter leave their home traveling in opposite directions on a straight road. Peter drives 15 miles per hour faster than Jane. After 3 hours, they are 225 miles apart. Find Peter's rate and Jane's rate. All right, so let's set this up. Since they're going in opposite directions, that's another key piece of information. The first one we talked about was going in the same direction. Then we went round trip, and now we're going in the opposite direction. So we're going to set up our table. Distance equals rate times time, and I have no clue why I made this so big at the end here, so let me erase some of that. All right, so who are we talking about? Well, we're talking about Jane and Peter. So, what do we know? Well, what's Jane's rate? Does it say how fast Jane is going? Nope. All we know is that Peter drives 15 miles per hour faster. So we're going to let Jane be, let's let Jane be R. We could use X or whatever. So if Jane drives R, how fast does Peter go? If Peter goes 15 more than Jane, and Jane is R, what expression are you going to put for Peter? Good. R plus 15. Now the time. What do you think the time's going to be? It's a trick question. It says after 3 hours. They leave at the same time. So they've both been traveling 3 hours. So now we know distance equals rate times time. So we take R times 3. So that's 3R. Here we take 3 times R plus 15. And we don't need the D's right now. So what do we know? We know Jane has an expression of 3R, and Peter has an expression of 3 times R plus 15. They drove 225 miles apart. So they are a total of 225 miles apart. So Jane's distance is 3R, Peter's distance is 3 times R plus 15, and they're at a total distance from each other of 225. So we have to add 3R. I'm going to move this up a little bit. We have to add 3R plus 3 times R plus 15 equals a total of 225. Let's distribute. 3R plus 3R plus 45 equals 225. 6R plus 45 equals 225. We combine like terms. Subtract 45, that gives us 6R equals 180. 180 divided by 6 gives us 30. So a rate of 30. Now who's 30? Who has R? It's Jane. So Jane travels 30 miles per hour. Peter, that's a really bad E. Let's try that again. Peter went 15 miles faster than that, so Peter's going to go 45 miles per hour. So Jane went 30 miles per hour, and Peter went 45 miles per hour. One last thing. Some people like to draw diagrams. And if you had a road and you wanted to say, here's Peter, and Peter went 3 times R plus 15, and here's Jane, and she went 3R, and you saw that their total distance is 225, and that helped you set up the equation, you can always draw a picture as well.